Use the number line to list the unknown values from least to greatest. In our number line, in between 0 and 150 would be the number 75. So we have to count by 75s the whole way on the number line. If I increase 150 by 75, that gives me 225. Then we write them in order from least to greatest. You do not need to write down the numbers that are already there. You're just listing the unknown values in order. Match each dataset description to the coordinate plane that is most appropriate for graphing the dataset. You'll notice that the scale on the axes, or the interval which they count by, are not the same in all of these graphs. A. Each point represents one city in the world. Let X represent the city's distance from the prime meridian in miles. Let Y represent the city's distance from the equator in miles. Well, in our globe, cities can be very close to or very far from the prime meridian and from the equator. So this is going to be letter B. We have a distance of 0 to a little bit over 6,000 miles. Each point represents one piece of fruit at the grocery store. Let X represent the store's cost to get the fruit in dollars, and let Y represent the price I pay for the fruit in dollars. Do we expect fruit to cost $500, $30, or around $2? If we're only buying one piece of fruit, it's likely going to cost approximately $2. Each point represents 1 month. Let X represent the number of days of sun and Y represent the number of days of rain. Well, there are 28 to 31 days in a month. So we wouldn't need to go all the way to 500. A little over 30 would be enough. And the last one should be C, but let's check and make sure that it makes sense. Each point represents one book. Let X represent the number of pages, and let Y represent the number of words per page. It makes sense that there's about 500 words on a page. In the graphs we have seen so far, we saw where the axes were the same. So they counted by the same thing on both axes, but that doesn't necessarily have to stay the case. You can see here that the x-axis counts by 2/10, but the y-axis is counting by 5s. As long as the whole y-axis counts by 5s, and the whole x-axis counts by 2/10, this is a perfectly acceptable graph. They do not have to match. They don't both have to count by 5s. We can have two different axes as long as they stay consistent. In our lesson, we're going to look at a set of points to graph on the coordinate plane. We're going to change the interval that we count by on the x and y axis, but graph the same set of points. So here is that list of points with their coordinates. In this graph, you can see they counted by 1s. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For our purposes, we're going to change those scales. So we might have 1s on the x and a different number on the y-axis. Let's try graphing A through H using an interval of 1 on the x-axis and an interval of 2 on the y-axis. All right, the coordinates for point A were 0, 4. So 0, instead of going up 4 boxes, we're going to go up to the number 4. And that is A. B was 4, 2, so we're going to go over to the number 4 and up to the number 2. Not up 2 boxes, but up to the number 2. C was negative 5, 0. D was negative 2, negative 1. Well, if we were going down 2 for each box, in order to get to negative 1, I'm going to be in the middle of that box. And that is point D. Oh, except D is positive 2, negative 1. So the other side, positive 2, negative 1. E is negative 2, negative 1. F was 0, negative 3. Negative 3 is in between negative 2 and negative 4. G, negative 4, negative 2. And H, 5, 0. For this next one, we're going to use a scale of a half on the x-axis and a scale of 1 on the y-axis. A was 0, 4, so 0 in the horizontal direction and 4 in the vertical direction. B was 4, 2, so we're not going over 4 boxes, we're going over to the number 4 and up to the number 2. C was negative 5, 0, so all the way out here to negative 5, and then 0 for the up and down. D, 2, negative 1. E is negative 2, negative 1. F is 0, negative 3. G is negative 4, positive 2. And H is 5, 0. For C, we're going to graph those same points. On the x-axis, we'll use 2, and on the y-axis, we'll use a half. A is 0, 4. Remember, we're moving to the 4, not just 4 boxes. B, 4, 2. We always move in the x direction first. Negative 5, which is in between negative 4 and 6. 0. D, 2, negative 1. E, negative 2, negative 1. F, 0, negative 3. G, negative 4, positive 2. H, 5, 0. Compare the graphs created from the alter the interval card to the given graph in problem 2. Describe the graph in part A compared to the graph in problem 2. Describe B and C compared to them. In the first one, the scale of 2 made them appear closer together. When we use a scale of a half, it makes them look more spread out. In C, when we use both 2 and 0.5, they look more spread out vertically. But closer together horizontally. For parts A and B, consider points A through E. Determine the appropriate scale for the x and y axes. Draw and label the coordinate plane. So when we look at all of these x coordinates, we can see that counting by fifths would capture all of the x values. For the y values, we're going to want to count by something bigger. For example, we might count by 50s for the y-axis. So this would be 1/5, 2/5, 3/5, 4/5, 1, 1 and 1/5, 1 and 2/5, 1 and 3/5, 1 and 4/5, 2. Then for the y-axis, we are counting by 50s. So we need to count by 50s going in the negative direction also. To graph the points, we're going to go over 1 and 1/5 and up 0 for A. For B, we're going to go over to 2/5 and down to 150 for B. For C, we're going left 4/5, 1/5, 2/5, 3/5, 4/5, and up to 200. D, we're going to 2 and then up to 100. E, left 1 and 4/5, 1, 2, 3, 4, and down to 50. 50, 100, 150, 200, 250. And you can just check off that we did both of those tasks. These are plotted and labeled. We've drawn our axes, and we've labeled the numbers. You might also say this is the x-axis and this is the y-axis, just in case you need to remember. The same type of process is going to be used here. Let's start by looking at the x values. Now at the beginning I was thinking I would count by tens, But now that I see 15, I'm thinking maybe I should count by 5s to capture those as well. For the y values, it looks like if I count up by a quarter each time, that would capture the 0.25 and the 0.75. We're going to begin by labeling our axes. Okay, but I've run into an issue. If I go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, that's not going to reach that number 70, so I'm going to have to adjust. And I am going to count by 10s instead. It'll be 10, 20, 30, 40, 50, 60, there's 70, 80, 90, 100. This would be negative 10, negative 20, negative 30, negative 40, negative 50, negative 60, negative 70, negative 80, negative 90, negative 100. Okay, and then for the y-axis, we are counting by quarters, we said. So this would be 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, 2, 2.25, 2.5, 2.75. I'm never going to reach 3.5, so I need to adjust. Let's count by halves instead. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, so that will reach it. All right, A, we're going over to 10 and up to 3.5. So here's 3, 3.5 is right here between 3 and 4. B, negative 70 down to negative 2. C, 0, negative 1.25. Well, this is negative 1, and this is negative 1.5, so we need to be right in the middle. D, negative 15. This is negative 10. This would be negative 20, so negative 15 is right in the middle. And then up 4.5. In between the 4 and the 5. E, 25. Here's 10, here's 20, here's 30, so 25 is in between 20 and 30. Down 0.75. Well, this would be down 0.5, so down 0.75 is in between 0.5 and 1. Both of these graphs show the cost to feed a dog, but they look a little bit different even though they have the same coordinate points placed on them. This shows for 4 days, it would cost $3 because it's in between 0 and 6. So for 4 days, it costs $3. That's this point here. Over here, here's the days again. For 4 days, well, in between 2 and 4 is that number 3. It also costs $3. For 24 days, it costs $18. Over here, 24 days, $18. So why does it look like it's cheaper to feed the dog in this graph than it does in this one? What's different about them? I see on the bottom it's counting by twos, and on the bottom here it counts by twos as well. But in the cost, you can see it's counting by twos for this graph, but sixes for this graph. So the way that we build our graph can alter the way that it appears to us, even though it has the same information on it. It has this point, and these ones have the same exact points, but this one appears to be steeper or more expensive just because the way that we've built the graph with the scale on the y-axis. So make sure that you're really interpreting what the graph is saying based on the coordinates, not just the shape that the graph takes. Make sure your warm-up is filled in and your workbook is as well for this lesson 13.